everyone, I'm Sab. Welcome to my presentation. So, this study is entitled Effects of Computer-Based Feedback and Formative Assessment on Learning Outcomes, delves into the transformative potential of student response systems, or the SRS, in a distance education setting. So, there are several fundamental concepts that are integral to understanding the paper. These concepts include student response systems, or the SRS, computer-based feedback, technology-enhanced formative assessment, and backward design. So these concepts play a crucial role in understanding how technology can be leveraged to improve student learning outcomes in distance education. The first key concept is the student response system. Student response system advances in digital technologies have enabled immediate and personalized feedback. So when we say personalized feedback, responses are tailored to each student's specific needs and performance, making it more relevant and impactful. So the use of SRS enhances classroom interaction and assessment by providing real-time feedback. So the key elements include provides individualized feedback. Next is the data can be either textual or numerical depending on the type of assessment. Lastly is enhanced interaction. What are the four examples of SRS that are commonly used? So the first one is the jot firm. Next is the Socrative. Third one is the Vivox. And fourth one is the Mentimeter. But in this study, the author used Google Forms as an SRS tool. The second key concept is the Technology Enhanced Formative Assessment, or the TEFA. So, as the name suggests, TEFA involves using digital tools to conduct formative assessments, and this concept leverages technology to make formative assessments more interactive, immediate, and data-rich. It also shifts the traditional focus of teachers and learners. So, for the key elements, TEFA uses a range of web-based tools to facilitate formative assessment. And these tools can include online quizzes, discussion forums, and digital feedback systems. And the use of ICT tools makes the assessment process more interactive and accessible. TEFA also includes asynchronous assessments. It can be administered through online platforms, allowing flexibility, and it also supports diverse learning needs. TEFA also incorporates synchronous assessments, which are conducted in real time, and this can include live quizzes, interactive polls, and real time feedback sessions during virtual classes. The third key concept is the feedback. So, feedback varies widely, such as assessing correctness, pinpointing areas for further development or enhancement, referencing previous contributions, and encouraging opinions or ideas. And it comes in different forms, and the most common ones are written and feedback. So, the fourth key concept is the backward design. Designing an effective curriculum is crucial, and it is important to identify a curricular design process that allows teachers to demonstrate their knowledge of content and select appropriate instructional goals and assess student learning. Backward design also stems from the learning centered paradigm and involves three strategies. Stage 1 is to identify desired results. So the first stage of backward design focuses on what the students want to achieve by the end of the course. So this means identifying what students should know, understand, and be able to do. In this study, the first stage of backward design involves identifying the desired learning outcomes for students in a physics course. So the stage 2 is about planning how to measure if the students have met the learning objectives. So this includes exploring various assessment options, which with an emphasis on assessments that help students demonstrate their knowledge and mastery of important content. So the study uses student response systems or the SRS and formative assessment to provide immediate feedback on student responses. Lastly, we plan the actual instructional activities and strategies that will help students reach their learning goals. Instructors decide on the formative strategies, activities, and resources that will be used throughout the course. The paper outlined planning of instructional activities must align with the identified learning outcomes and assessment methods. And the integration of SRS with platforms like Google Forms is a key strategy. So here's a brief overview of what I'll be discussing in the summary. First one is the research problem. Next is the design. Next is the methodology. Then findings. Lastly is the conclusion. Let's now proceed to the research problem. So, the research problem addressed in this study is feedback and formative and scarcity. And the first problem is examining the effects of integrating student response systems into computer-based feedback and formative assessment on the academic achievement of first-year electrical and electronic Vietnamese students. The second problem is that there is a scarcity. So the author mentioned that there is a scarcity of students focusing on the use of SRS and technologically enhanced formative assessments within the context of Vietnamese education. Identifying this gap highlights the need for further exploration of these approaches to document the education needs specific to Vietnamese students. Let's now proceed to the research methodology. So the research methodology is broken down into several components, and those are research design, participants, teaching process, and data collection methods. Here in the research design and participants, the study involved a total of 148 male Vietnamese students who were selected randomly from 2 out of 8 classes of electrical and electronic classes, employing a quasi-experimental design consisting of experimental and control groups. In a quasi-experimental design, participants are usually divided into experimental and control group. So the experimental group receives the new method, which in this case is the integration of student response systems to deliver both formative and feedback, while the control group continues to use the traditional teaching methods without the new method. In addition, in this type of design, pre-tests and post-tests are usually conducted to compare the results. Let's proceed to the teaching process in the study. So for the curriculum integration, the physics general program for the study covered a total of 60 teaching hours, including topics such as force and motion, energy, solid mechanics, and lastly is the electricity and magnetism. The specific focus for this study was on the energy topic, which consisted of 6 teaching hours. The intended learning outcome was for students to be able to apply the conservation laws of energy and momentum to tackle complex and real-world scenarios. So now let's talk about the instruments. As you can see here, I'm showing the Table 1 questions classification based on Bloom's taxonomy for pre-test and post-test. So the study used 20 items multiple choice questions and is structured according to Bloom's taxonomy, covering levels of remembering, understanding, applying, and analyzing to ensure a comprehensive evaluation of the student's baseline knowledge. To ensure the reliability of the instrument, a pilot study was conducted with 45 first-year students who were not part of the main study. So the reliability, on the other hand, was determined by adopting the Coder-Richardson 21 formula. So now let's proceed to the data collection methods. We have the pretest, The data collection process began with conducting the pretest to both experimental and control groups. So these pretests used the multiple choice questionnaire designed to evaluate a student's baseline knowledge on the energy topic. And the test was conducted for 45 minutes before any instructional intervention took place. And then next is the intervention. Following the pretest was the intervention phase. The experimental group received teaching that incorporated feedback and formative assessment strategies. So for 6 teaching hours, focus on that energy topic. Students in this group use a student response system to receive real-time feedback, which promoted interactive learning and allowed for immediate adjustments based on a student's understanding. And on the other hand, the control group was taught the same content over the same 6 hours period, but without the integration of feedback and formative assessment strategies. Instead, traditional teaching methods were employed and no real time feedback was provided during the instruction. After completing the instructional phase, both groups were given a post-test to assess their learning outcomes. These post-tests consisted of the same 20 multiple choice questions items as the pre-test, but the items were reshuffled to prevent any recall bias. So what are the findings? Results collected from the pre-test and post-test were compared to determine if there were significant changes in learning outcomes between the experimental group. So the first one is the study revealed that the experimental group showed improvements based on their test scores. And then next is the integration of technology can enhance interaction between learners and teachers. So what are the conclusions? Based on these findings, the main conclusion from the study is that the use of technology enhanced formative assessment or the TEFA, specifically using tools like SRS, is highly effective in improving student learning outcomes. In the context of distance education, integrating technologies like SRS can address some of the challenges of distance education since it enhances engagement and it provides real-time assessment feedback. Let's now proceed to the distance education and assessment theory. Self-regulated learning. So central to the study is the practice of providing immediate feedback, and in the context of science education, as highlighted by Ganajova et al. In their paper, evaluating a student grasp of fundamental concepts must include assessing their practical application in scientific practices. This aligns with the specific learning outcomes in the paper, which emphasizes applying energy and momentum conservation laws to solve real-world problems. And an essential component of this approach is fostering self-regulated learning among students. When I say self-regulated learning, it is a critical approach in educational psychology, referring to how students control and manage their own learning processes. And as stated by Zimmerman, self-regulated learning includes proactive management of the learning process through metacognitive, motivational, and behavioral strategies and beliefs. He also stated that it involves 3 iterative phases. The first one is the forethought, next is the performance, and then last is the self-reflection. So as you can see here in the figure 1, it shows the phases of self-regulation in learning via formative assessment. So the first one we have is the forethought phase. So in this phase involves the initial planning and goal setting before engaging in a task or activity. Next one is the performance or the control phase. So during this phase, individuals engage in the actual execution of the task, and it includes activities such as self-monitoring progress, adjusting strategies as needed, and maintaining focus on the task at hand. And then we have the self-reflection phase. After completing the task, this phase involves reflecting on one's performance, and it includes activities such as self-evaluation of performance against goals, identifying strengths and weaknesses, and adopting future strategies based on feedback received. We also have the community of inquiry. So, community of inquiry model developed by Garrison, Anderson, and Archer provides a framework for understanding the elements necessary for a successful online learning experience. And it is also designed to understand the dynamics of online learning environments. It integrates three interdependent elements that are crucial for a successful educational experience. The model comprises three interdependent presences. First one is the teaching presence, cognitive presence, and lastly is the social presence. In the community of inquiry, there are three core elements. The first one is the teaching presence. The teaching presence is all about setting the stage for learning. It is where instructors design and organize lessons, set clear learning goals, and provide feedback to guide students along the way. Think of it as a foundation that keeps everything structured and focused. Next is the cognitive presence, so it refers to the extent to which learners can construct and confirm meaning through sustained reflection in the course. It's about how students engage with the material, think critically, solve problems, and integrate new knowledge. Last one is the social presence. So, social presence serves as a glue that holds the community together. It's the ability for students to identify with the group, communicate effectively, and build relationships. And what are the assessment strategies? So, the assessment strategies that used in this study are, first one is the formative assessment, continuous assessment during the learning process to monitor a students' progress. The second one is the feedback, providing real-time feedback using the SRS to help the students understand their current knowledge state and make necessary adjustments. Lastly is the pre-test and post-test. Multiple choice questions tests were used to evaluate the students' knowledge before and after the intervention. For the sample distance education scenario, we have the digital design course in distance education mode. So who are the target learners? The target learners are undergraduate students enrolled in a digital graphic design course. And this course includes Adobe Creative Cloud for design software tools. And then we have the Behance for showcasing and reviewing student work. And we also have the Google Forms for quizzes and formative assessments. And then we have Zoom for live classes and interactive feedback sessions. And then Discord for real-time communication and collaboration among students. So now let's talk about the needs. The educational needs addressed by the course, such as the practical application of the design principles and software skills. It underscores the importance of providing immediate and constructive feedback on design projects to foster continuous improvement. And additionally, it emphasizes the value of collaborative work and peer review opportunities in enhancing learning outcomes. And the next one is the personnel. It includes instructors responsible for leading classes, providing feedback, and facilitating discussions. Teaching assistants are also mentioned who assist with platform management, grading, and student support. Additionally, student support to troubleshoot any technical issues encountered in any of the educational technologies. Lastly is the course learning developers ensures that the instructional materials within the course program are high quality. Then also we have the policy. These are the policy consideration essentials for the course. Number one, it covers the assessment policy that includes guidelines on the types of feedback provided to students and on the frequency of feedback. Lastly, the technology use policy sets guidelines for the effective use of the educational technologies within the course, and it ensures that tools like Adobe Creative Cloud, Behance, Google Forms, Zoom, Discord are used in ways that support learning objectives and maintain a positive learning environment. So, what are the challenges and limitations in this study? So the first one is the feedback quality. The quality and depth of feedback provided through the SRS were not discussed, and effective feedback should be specific and timely. The second one is the implementation of the SRS. The study used Google Form as the SRS tool, which may not be fully leveraged. The interactive and real-time feedback capabilities of more sophisticated SRS technologies. Then the third one is the assessment variety. The study primarily used multiple choice questions to assess learning outcomes, which may not fully capture students' understanding and higher order thinking skills. What would be my recommendation? First recommendation is to ensure that the feedback provided through the SRS is detailed and constructive, and instructors can be trained to give effective feedback. The second recommendation is to use other SRS tools that offer real-time feedback analytics and enhance interaction features. My third recommendation is to incorporate a variety of assessment methods such as open-ended questions. This can provide a more holistic view of student learning and understanding. So these are the challenges associated with using student response systems in distance education summarized in the study of Kay and Lesage. So the first one, we have the technology-based challenges. Signals from remote devices do not register on the instructor's computer, and this can be particularly stressful during the graded evaluations. And additionally, issues with device functionality can prevent students from participating, as highlighted by Caldwell and Rayari. The instructor-based challenges, so when it comes to responding to student feedback in real time, less experienced instructors may struggle to adjust their teaching strategies, and the use of SRS can reduce the amount of course content covered. So furthermore, creating effective SRS questions is time consuming, as noted by Abrahamson and Allen and Tanner. For the student-based challenges, from the student's perspective, adapting to new learning methods can be difficult. Increased discussion facilitated by SRS can sometimes lead to confusion or wasted time. And additionally, the high effort required from students and the impact of negative feedback can be discouraging. And this is supposed by research from Alden and Tanner and Draper and Brown. To address the challenges, it's crucial to prove clear guidelines and expectations for student participation in SRS-driven discussions, and in that way, it can be minimize confusion and optimize learning time. Next is to diversify the SRS tool. Platforms such as Socrative and Mentimeter can be used, offering a broader range of question types and interactive activities along with enhanced features. Third one is to incorporate different assessments, not only relying on the multiple choice questions. And the next is provide effective and constructive feedback. So in the Socrative platform, you have the ability to create quizzes by clicking the quiz, and you can launch a template here in this example, which is the word facts quiz, and you can select different options. So for the settings, you can toggle require name, and you can also select different types of navigation and teacher based. After clicking launch, you will see a real-time table where you can watch students complete their assessment. See? And also to invite students, you will be getting an auto-generated QR as well as a room name. In my case, my room name is Luis7208. So you can finish the activity and export the results in your drive. And there's also live results option. Space race, you can ask quick questions. Alright, that's about it. Thank you everyone for watching and have a nice day to all of you.